Hello again, sixth graders. You recognize this board. This is the one we developed in the last video, and I tried to sell this as a complete picture, but it isn't quite. Two things to say, and they're going to end up being related. The first is, I said during the previous video that it just so happens that with number 2 you get 4 ways to represent the -9 plus -4. With number 1, only 2 ways to represent the 9 plus 4. With numbers 3 and 4, 3 different ways to represent those. I kind of left it at that. Well, a natural question would be, why? And is it possible to represent the first one 4 different ways, and numbers 3 and 4, 4 different ways, just like number 2? What's special about number 2? Well, all of these 4 additions can be represented 4 ways. The reason I avoided it the first time is they're kind of unnatural, in a sense. It doesn't seem natural to try to indicate that 9 plus 4 is 9 minus -4, but it is. So here's how we can add another way of representing 9 plus 4 up there in the number 1 problem. I've presented subtraction, I've defined subtraction for you as the addition of an opposite. So to subtract -4, add the opposite of -4, which is 4. 9 minus -4 is equivalent to 9 plus 4. And in a similar way down here, of course, the 4 plus 9 could be represented or thought of as 4 minus -9. You will, in the course of your math lives, run across this kind of thing now and then. You wouldn't necessarily go to it from 4 plus 9. That was my point about how it's kind of unnatural. But when you get into algebra, some high school algebra situations, or even in 7th or 8th grade, you're going to come across subtracting a negative, and you'll have to know how to handle it. 4 minus -9 is the same as 4 plus the opposite of -9, so it's 4 plus 9. So now we have 4 ways of representing the 9 plus 4. Just like there were 4 ways of representing the number 2 problem. And up here with number 3, the way we can sort of squeeze out another way of representing number 3, we notice that we have a plus 9 here. So we could represent -4 plus 9 as -4 minus -9. So I'll just squeeze that one in there. It's not something that naturally occurs to us, but the subtraction of a negative number can be handled. -4 minus -9 is equivalent to -4 plus 9. To subtract -9, add the opposite of -9, which is 9. So there's a 4th way of representing the number 3 problem. And when we look down at number 4, the place that we're going to find where we can have another version of the problem is when we see the plus 4. See, these two, you can't really go do much more with these two. You know, adding -9 being the same as subtracting 9. That's pretty much it for that kind of look there. But here, -9 plus 4, that could be represented as -9 minus -4. I really should have written it in right underneath here, but I didn't have much room, so I put it down here. If you had -9 minus -4, you would interpret that by definition as -9 plus the opposite of -4. So it becomes -9 plus 4. So now the purpose here was, number 1, to round out the picture and show you that there really are 4 ways to represent each one, and also to remind you that you're going to have to be able to handle that subtraction of a negative. But it's still within the overall definition of subtraction, which is to subtract a number, add its opposite. So that is, I think, truly it. Here's the totally complete board now. And you might want to, as I suggested last time, reproduce some of these on your own with different numbers. Take care, 6th graders. Bye-bye.